If you're not using AI, you are just slower. The future of software engineering is you telling your computer, here's exactly what you need to build, and it just happens.
It's $1 trillion market. How do you think of the possible value and opportunity of something like Devin?
We can do not just like 10% or 20% gains, but more like 10x.
Why is it all these math people are so good at AI?
I go to Glasgow Middle School and I'm in 7th grade.
What is the value of 255? Scott?
5,000.
5,000 is the correct answer.
This company you're building, you're hanging out with these top minds in math and physics and competitive programming.
So we do a lot of we do a lot of math games for sure.
First person to solve it in the comments, we're going to send you some swag. Scott, what's a harder one?
So if you have code is honestly the fastest growing use case of AI out there. We've been spending our whole lives in Minecraft survival mode, and now we're going to get to play Minecraft creative mode.
CEO and co-founder. Joe Lonsdale, the founding partner of Palantir co-founder Joe Lonsdale.
Scott Wu was the world champion in competitive programming at the IOI after winning multiple gold medals. He used to work for me 10 years ago at Adapar, and today he's the CEO and founder of one of the fastest growing AI companies in the world. He's surrounded by a lot of the top minds in math, physics, competitive programming. They're building one of the fastest growing companies I've ever seen. What are the top minds in the world? Think about AI. Where's the world going to be in 5 or 10 years? And can you solve Scott Wu's math problem? Welcome to American Optimist. Really excited to have my friend Scott Wu here with us. Scott, you're the CEO and founder of Cognition AI. You were the world champion at the IOI competitions, top math competitor, and your company's doing awesome. Thank you for joining us.
Yeah, no, thank you so much for having me. I mean, it's exciting to be here. I mean, it's for a few reasons. I mean, first of all, I am actually American and an optimist, and so it's exciting. But also it's we've known each other for like 12 years now, and it's Joe actually gave me my very first job. I was an engineer at Adapar 12 years ago.
You were a superstar at Adapar. It's cool to see you go on to build like one of the giants in Silicon Valley. Hopefully, it looks like. But let's step back a bit. So about a year ago, you guys released a demo of Devin, which is what the product of Cognition's called. Did you have any idea it would go so viral? Like, what surprised you?
I mean, no, not at all. We hoped it would go well. You know, we put a lot of energy and effort into it, and it was it was really awesome to see. I mean, I think it's. We have always had the view of just skating where the puck is going, basically. And around end of 2023, we were working on AI and specifically AI for coding. And we felt that things were going to shift a lot more agentic, basically. And everyone's talking about agents now, but back then it wasn't really a term. You know, at a high level, we were kind of we had the view that instead of pure text interfaces, there's going to be a lot more full interaction where AI systems could not just read text and answer questions, but actually just go and interact with the real world. And in code, obviously that means debugging, pulling up the logs, reading documentation, testing code yourself, and so on. So
well, it's amazing. It's $1 trillion market. I want to dive more into that, but before we do that, Scott, let's go to your background. You're from Louisiana originally, right? That's not exactly the epicenter of the math and programming world. Like, what made you interested in these topips?
Yeah, but your dad is from Louisiana as well, right?
You spent some time there managing a plant actually when he was younger. That's true.
So yeah, no, I mean similar story for me. I mean, both my parents were chemical engineers. They immigrated from Shanghai in the 80s, and yeah, I mean, it's naturally there's a lot of oil and gas emissions and so on, and so my parents both worked in basically the emissions industry in Louisiana. I grew up in Baton Rouge, and it was not a lot of people who did math and programming in Baton Rouge, but I mean. I always loved math. I had an older brother also that did a bunch of math and programming competitions and first got me into it. But yeah, it's something that I knew I wanted to do from very, very early on.
So in our family, my dad ran a plant there, and he was a chemical engineer too, is why he was there. And then my wife's grandfather ran an oil plant there. So you do get a lot of talent, I guess, coming through that way. But it's not seen as a center for these things. So you got into competitive programming. How old were you when you first started doing that?
Yeah, so my first math competition, I actually still remember, my first math competition was in 2nd grade. So I was like 7 or 8 years old. There was this, the local college held a math competition for like middle schoolers and high schoolers. And so I was competing, I think, in the 7th grade division. So it was like me and a bunch of 7th graders basically doing math competition.
What kind of problems was that?
It was like, it's a lot of the typical stuff for 7th grade math is probably things like, I don't know, it's
Give
like
us one.
exponents or something, fractions or whatever, like the standard problem where the frog is at the bottom of the well and goes up and falls down every night and stuff like that, basically. But yeah, it was, I remember it because they were calling out the awards. And so then they called out, 3rd place and 2nd place and 1st place. And none of them was me. Like I didn't win, and I was really, I was like 8 years old, but I was like really,
You're disappointed. You
really
didn't win.
disappointed. Yeah, I was really upset about it. And so then the next year I trained a bunch. I competed in Algebra 1 the next year when I was in 3rd grade, and then I won, and then I kept doing math competitions from there. And then programming competitions, it was I started around middle school, and so around sixth grade. I learned to code when I was in 4th grade or so, and then I started doing some of these programming competitions when I was 6th grade, and I always loved them. So,
as an aside, right now in the Bay Area, I think you have a lot of the top competitors happen to be Asian, happen to be based in the Bay Area. But it's interesting because they're actually dropping a lot of the honors courses in math and other things in the Bay Area. Have you followed this? What do you feel about that?
Yeah, I mean, it's sad. I mean, I think I'm only here because of advanced math classes. It's kind of what I would say. And I think growing up in Louisiana, folks were really nice and really supportive. Honestly, there were a lot of people basically at all levels that kind of allowed me to, I was taking, I grew up in, I went to a school called Buchanan Elementary School in Baton Rouge, and it was right next to this high school called McKinley High School. And because of a lot of hard work from folks, basically, things were set up so that I could actually have someone walk me over every day to go to the high school to take math classes at the high school. And it's obviously, I mean, I think I think it all obviously starts with math and with just technical education. And so, no, it's a very near and dear to my heart.
My friends and I actually got walked also to go to the higher schools. There's a group of us, 6 of us, and they helped me build Palantir later. So it's interesting. I don't think we were quite as advanced as you, as many grades, but it was really important. And I'm told nowadays they wouldn't allow that to happen anymore. So I guess equity means that they have to pull us down now, which is too bad. But you were crushing these contests. Where'd you go to college? How'd that work out?
Yeah. Well, so before I went to college, actually, I worked at Attapar. I was there for a year and a half.
And why'd you do that? Why didn't you go right to college?
Yeah. So it's after high school. I was coming out of it. I had done a bunch of these competitions. I think at that point already, I really felt like I wanted to start my own thing at some point, which is funny because I don't think I knew what that meant. It was there was apparently people. I don't remember this, but people tell me this that when I was in 4th grade, I had a math teacher at the high school, and I told him that I was gonna start a really big company someday, and then I was gonna give him a position as a software engineer.
You still owe him the position, Scott.
Well, we got some work to do to get there first. We're gonna build a big company first, and then he'll have the software
the
engineer
signature,
title.
huh?
Yeah.
Okay.
But I obviously had no idea what that meant, so I'm not sure what I was talking about at the time. But yeah, it was like I mean, it was really exciting to just see technology move and see real companies get built, and I wanted to learn what that was like and what that was in the real world. And so I took a year off, a year plus both of the summers around it, and I worked at Attapar. And it was a lot of fun. It was basically I was on the computational architecture team. I was figuring out how to compute a lot of big financial metrics for a lot of these.
Well, we have $8 trillion on the platform now, so hopefully some of your insights are getting used at scale. I appreciate it.
Yeah. No, it was a lot of fun. And then after that, I decided that after all, I would go to school and try out school for a little bit. I wanted to, less so, I think, to learn software engineering, and more so to basically meet interesting people, take classes, and just kind of develop personally. I was at Harvard for about 2 years, and then I dropped out and started my first company, and it was a great experience. Yeah.
And your first company was called Lunch Club, which I remember writing a small check into saying, I think it's a bad idea. But actually, you guys, they figured out eventually something really good there. But tell us about that.
Yeah, absolutely. So Lunch Club, it was, we started in 2017, which is way before kind of generative AI. But the whole idea was we used AI to make the right professional connections. And so folks would come in and they would tell us, their interests and their goals, and then they would also give us access to their contacts and their calendar. And based on that, we could figure out who were the right people for them to meet. It was all in-person meetings. Up until COVID happened, and then we had to support video meetings as well, which was a fun journey. But it's I was there for about 5 years. We made We made millions of meetings. It was a really fun journey, and I feel like it's taught me a lot of the lessons that I take.
And Vlad, who you built it with, was obviously someone who's an amazing recruiter of talent, and I think he's pivoted to something that's working. So it's no surprise he's going to make it work. What was the inspiration for starting Cognition?
Yeah, so it's it was a fun journey. Actually, a lot of it came back to these math and programming competitions that I did when I was a kid, and so I was still super tight with a lot of these folks. It's like we would do these math competitions in middle school, we would do these programming competitions and math competitions in high school. A lot of folks went to either MIT or Harvard, and so people were pretty close by as well. And then naturally, many of those people were working in AI, and so there was kind of a core group of us who we'd all spent our last 10 years basically like building in AI and thinking about AI and building different companies. One of my co-founders, Stephen, was the first engineer at a company called Scale AI, which is doing incredibly well. Yeah. My other co-founder, Walden, was the first engineer at a company called Cursor. So we had all done a bunch of different things, and there was a point where we basically all got together and said, let's try and just do some projects together. It wasn't a company at the time. It was just like more of like basically like a research project, messing around with some ideas. We rented a house here in the Bay Area and then just got a bunch of people together for like 2 weeks and hacked on stuff together. That was November of 2023. And then in December, we got another house in New York and we got everyone together and hacked on a bunch of stuff. And then in January, we got another house. And in February, we basically just kept doing the Hacker House model. And eventually, I guess there was, we incorporated a company, but that really came later.
That's awesome. And you really obviously brought together an all-star cast. You mentioned founding engineers at all these top companies. These are your smartest friends from the math, from the competitive programming world. Like, why is it all these math people are so good at AI? Is this raw IQ? Like, what's going on here?
Yeah, I mean, I think it's, and I think it's to an extent, it's always been the case in tech in Silicon Valley. That a lot of the smartest people. One of my favorite things is Mark Zuckerberg actually was a competitor on Topcoder. You can find his profile on Topcoder. He was a competitive programmer. And it's a lot of the initial folks who built that with him, like Adam D'Angelo, for example. Adam D'Angelo was like an international medalist at competitive programming, and so it has always been here for to an extent, but I think it's especially true in AI. And it's actually it's crazy to the extent to which it is. I think like OpenAI, Anthropic, Google DeepMind. I mean, a lot of these folks are like the folks running all of these big labs, and then of course like the folks running a lot of these startups are actually, people that I've known for more than a decade now, just from
that circle,
these communities. I think there's a couple reasons for it, but one thing I would just call out is, I think AI is. I think that the balance in AI does just inherently swing a lot more technical. There are a lot of pure technical problems that if you can just solve these really, really hard problems, it is incredibly clear, what happens and how you turn that into a business.
I want to stop you there and get one of these. Are not all of our audience is going to understand, but try start at the level that's like advanced, but not crazy advanced. Like, what's one of these hard problems you've solved? Can you tell us about this?
Yeah, for sure. And so in these Olympiads, for example, like a lot of the problems that come up are things like, you're in a network grid and you have to go find the shortest path between a bunch of places, but certain roads get blocked over the course of the day, and you're adjusting and you're still solving for these paths over the course of the day, for example, and you have to support all of this and make this run really, really fast, right?
That's like that's an NP complete problem, right? As I'm told, right?
So this one actually, it turns out there's some really sick things that you can do, but these are the kinds of problems that folks think about, and the cool thing is that every problem is unique. It is not about being asked something that you've already seen. It is all about coming up with a new algorithm, which could be based on things that you've studied or understood, but it really is like doing the first principles thing.
So just for intuition, again, for the listeners, why was that road problem tied to a real life thing that matters? Give us some more.
You're obviously not doing literal shortest path problems in AI, but I think that a lot of the pure technical problems that exist in AI are a lot of these things of basically. Training AI models that can solve really tough problems, or understanding exactly what the right architectures, the right systems are for AI to be able to go and do these things. And I think, with software engineering in particular, I'm obviously a programmer myself, and so it's a fun thing to get to spend time on, teaching AI how to code as a programmer nerd myself. And it is like, I would say a lot of it is really like thinking about thinking. It's how do we. Somebody hands you a bug, and how do you fix the bug? And maybe the answer is, you go and you run the code locally, you you reproduce it yourself. Once you figured that out, you go and find the error in the logs, you look at those files and you understand it. But a lot of it is teaching AI systems to do those same things, and there's a lot of kind of thinking about thinking that goes into it.
I love it. I feel like your social IQ has gotten like a lot higher the last 12 years, and you're being really careful not to tell us anything that's too complicated for us not to understand. But I want you to like go past that for a second.
Yeah.
And like what's like an example of something that not everyone's going to understand this that you solve there with this.
Yeah, absolutely. I think the broad in generative AI, everyone talks about kind of the whole generative AI wave. I actually think it's two waves. The first wave was kind of what I'll call like imitation learning, and the second is more like RL, reinforcement learning. And the really cool thing about RL is you basically can. I think the natural conclusion of RL, which is what we're kind of getting to, is you basically can solve any benchmark, which is insane to think about.
What does that mean?
Which means like if you have a clean set of environments, if you have a good feedback loop to decide what is correct or incorrect, you have all the necessary context that you need to make those decisions, you can train a model that just aces that. Which is, we're seeing that in practice on a lot of these things. Actually, it's funnily enough, like a lot of the benchmarks that people evaluate models on today are actually just the math and programming competitions themselves that we all did when we were kids, which is partially maybe because all of us are math and programming nerds, but partially also because it's, a clean way to just kind of see how good the models are at reasoning about hard problems. But yeah, I mean, it's one of the cool things there is it just means that, if you think about what happens next, a lot of what happens next is really just like understanding and really defining the benchmark. And so in practice, what that means is figuring out exactly what are the use cases and tasks that we want to solve for? What are the right set of tools that an agent should have access to? How are you going to evaluate success or failure? One of the reasons that code is growing so quickly is because you have this really great feedback loop of success or failure, right? It's, in healthcare or in law or something like that, it's a lot harder to say, whether you did the right job or not. In code, you can run the code. And so that's often the feedback loop that gets things to work. But that's kind of the core.
Scott, not all of our listeners are in the computer science world here in Silicon Valley. What does Devin do? Just basics. What is this?
Yeah, so Devin is an AI software engineer. And basically what that means is it's an autonomous system that you can work with the same way that you'd work with a human engineer. And so you can assign a bug to Devin, you can give Devin a task. Devin will go, it'll know your code base, it'll be able to test itself, it'll be able to iterate and work on things, it'll produce a code diff, a pull request for you to review and look at, and you basically work with it as your own junior engineer.
So Devin's being used by a lot of large companies. I'm noticing there's a lot of large enterprises doing like these big, giant, multi-billion-dollar adoptions and whatnot. And how do you iterate and figure out what's working or not in there? Like, what are the milestones to see what's working or not that you're learning from in these environments?
Yeah, for sure. And so with these, it's a lot of the general setup is, we want to look for the right use cases where we can do not just like 10% or 20% gains or 10%, 20% ROI, but more like 10x. And so we pretty routinely see spots where we can make things like anywhere from 6x to 20x more efficient.
What does that mean? 20x more efficient means you build something over the weekend that would have taken you months. Is one example I heard.
Exactly. So it means every hour of an engineer's time at that company on this particular use case using Devin is equivalent to 6 to 20 hours of an engineer's time not using Devin. And practically, obviously, what that looks like is basically just reviewing the code that Devin puts out and just making sure things look good and then just kind of signing off on that. But yeah, in practice, in enterprises, a lot of what that looks like is the cool thing about it is it turns out it's a lot of the kind of more tedious, repetitive stuff that human engineers don't want to do, which is kind of a nice. I think there's this really beautiful synergy of AI and humans, which is that AI has always kind of been good at the more boilerplate side of things, right? At taking on these more repetitive tasks, which are also nicely, the humans want to be able to work on the higher level strategic decisions or the creative side of tasks.
This is interesting though, because this is man-machine symbiosis originally with like Licklider in the 60s is you do the automatable things, the computer, and then the higher level with humans. And in chess, we always talked about this, but then eventually it got good at everything, and it was better than humans at everything. And it's like there's this funny joke where you're not married yet, but like there's like a husband and wife will agree, like the husband gets to make all the big important decisions and the wife can handle the small things. But then after like 60 years of marriage, the guy says it turns out there were no big decisions. Yeah. And so, but it's like if you give something a small things, eventually it's gonna get everything, right? It's like how do you think about that?
Yeah. No, it's so Andrej Karpathy has this phrase jagged intelligence, which I really love, and it basically just means that you can think of humans with our intelligence, we're kind of uniform, or at least from our perspective, we are. Where, as a kid, you grow up and you kind of just get smarter and smarter in a lot of different fields. Whereas with AI, there are certain things which is incredibly superhuman at, and then there are certain things that it is incredibly bad at, right? Yeah. And one of the cool things about jagged intelligence, I'll just say, is it means that humans plus AI really is the way to go, at least for the foreseeable future, right? Because I think there are more and more things that we're seeing that the AI is just able to do incredibly, incredibly well. But as long as that kind of tail exists of all the things that humans can do, that is what we'll own. And if anything, we'll be able to just do a lot more.
How long do we have, Scott? How long until it gets so long too?
Yeah, and I think the long tail will take quite some time, and I think there are some things that are honestly inherently human. I think it'll always be up to us to decide what to build, for example. And I kind of think that the future of software engineering is basically that. We talk about programming languages and architectures and all these things, but at the end of the day, the whole point of software engineering is just to tell your computer what to do. Right. And you should be the one deciding what to do, and you should be able to express that cleanly and just have it built. And I think that's kind of what we're going to get to over the next, I'll call it like 5 or so years, is a point where software engineering, we might even still call it software engineering or programming or whatever, but it really is just you telling your computer, here's exactly what you need to build. I'm gonna, let's add a new page on this website, or let's add a new table and store this and that information and just make sure this is ready to load, or this button could be a little bit rounder. Let's go and do that, and it just happens.
Will there still be a role for people who are deeply technical to iterate with the computer better, or can it just be like a random person listening to this who's never studied computer science is going to be basically just as good at doing all these things? Yeah,
and that's the thing, which is I think the answer actually is both. I think folks who are not completely non-technical are going to be able, we kind of see this already, right? Where it's so much easier already for people to build kind of websites or apps or something like that, even just from plain text. At the same time, obviously there will still be a lot of moments where you want to kind of peel back the layer of abstraction and be able to understand exactly, okay, what is really going on here? I think a parallel that comes to mind for this is basically no one writes assembly today, with the exception of folks who are really, really optimizing for very high performance work, right? Where they want to get in deeply and understand every single command that gets run. Yeah. And I think it's going to be kind of like a similar new level of abstraction on top of programming, where it's, I think folks will not have to dig into the details of what exactly the machine is going, but I think having these deep abstractions and really understanding what's going on is, of course, just still going to allow you to get to another level of making the right design trade-offs and decisions and so on. So.
Yeah, no, it's interesting because to be really good as a CEO in the Valley, you have to understand the things a couple steps down. And to be a really good product leader, I think you do have to understand some amount of engineering in order, because you have to know what's possible. You have to know the frameworks. It just seems very unintuitive to me that someone could build a whole product without having some sense of the architecture and the trade-offs. Right?
I was going to say, it's, computer science classes, for example, arguably they actually don't teach you, how to go and build real world software
or their concepts
and stuff. It's a lot of it is more just, how do you think about breaking down logical problems, right? How do you think about algorithms? How do you think about the model of a computer and what a computer can and cannot do, right? And I think a lot of it's people ask me all the time, it's my son or daughter is 16, should they even be studying computer science? And I always say, yeah, absolutely. And I think the reason is because these are, the concept level things that actually allow you to be a really good thinker about deciding what to build. So.
No, and I think we're going to need more people who have good at logic and are able to build things. That's for sure. It's interesting because the demand seems like it's going up for software engineering, and the more you make it cheaper, the more the demand goes higher, right? So right now, what is it? It's about $1 trillion a year we pay engineers. Do you know what the numbers are?
It's multiple trillion. Yeah, there's
multiple.
There's about 30 million software engineers in the world, and my favorite stat that I always love to share is right around the turn, the 1999, 2000, which was internet boom. Obviously, these things were, these things were becoming really, really big. There were actually less than 1 million software engineers back then. And
really?
So
wow.
the thing that's kind of interesting, I think, is, to your point, we have never really run out of demand for software, and if anything, already over the last, from 2000 until now, if you just think about Python and React and cloud, we've done a lot of things that have made it much easier to go and build software. And yet, of course, the number of software engineers has gone way up because we've just done way more things with software, right? And I think we're going to see something similar here, where it's, imagine imagine what we will do, when we get to the point where everyone can just build products and websites and apps and whatever it is of that level of quality of some of the best apps out there. We will just build a lot more of these. And so
It's very interesting because a lot of people are worried, for example, the Indian economy has like these 5 giant software firms where it's like long tail outsourced software engineering. And a lot of people are saying all these agents are going to compete with that, but there's a way in which the agents can just like make those people more productive. Is what you're saying.
Yeah, and look, the skills will change certainly, and I think this kind of pure implementation version, is it's going to be different in a few years, but I think a lot of the fundamental skills of building software, if you think about, as a simple example, it's even today, if we say, oh, this person, they're like a really great engineer, what do we mean? Usually it's not that they like type really fast or that, right? A lot of it is that they are just really good at thinking about these abstractions. They understand every case and every detail. They know about all of the, the kind of like higher level decisions that have to be made to build and architect something well, right? And I think that is the general shift where over the next few years, things will move more and more to that in terms of what human engineers are spending their time on.
Okay, so I want to ask you about the culture of Cognition, this company you're building. You're hanging out with these obviously top minds in math and physics and competitive programming all together, and like all these cultures are probably there late at night together all the time and doing stuff. And Devon's growing all over the world. It's gone viral in Japan. It's gone viral all around the U.S. And I was mentioning earlier, my little brother is like, at first he was like critical of this when it came out. It just didn't work for what he wanted, and now his whole company's using it to be way more productive. And which is a really good sign because if little brother's always negative on things you're doing, so it's like it must be good then. But so you guys have this amazing thing is growing. Like, what's the culture internally, and like, what do you talk about the future? What are you guys thinking about it? And by the way, when you hang out, I hear you play math games with each other. Like, tell us about this.
Yeah. So we do a lot of math games for sure. No, I think look, I was saying from the beginning that we started in a house and we did another hacker house and we did another hacker house. And in some sense, we never really stopped doing that. I feel like it's been a hackathon for like the last year and a half. And it's, we have about 30 people on the team today. And one of the crazy things is actually, we have a lot of people who came from this kind of like, Olympiad background in math or programming. But we actually also, 19 of us, I think, were founded a company before, 19 or 20 of us.
Wow, so you got a bunch of former founders.
A bunch of former founders, and I think it's
cool.
an experience that's relevant, I think, in a lot of different ways. And I certainly had the same experience as well building Lunch Club, which is you do run into a lot of these challenges and learn a lot of these things, but it gives you a lot of fire, I'd say, for all of us to just be like, this is the one. We're gonna make this the really, really big one. We're gonna make this the massive success, and that's what we're all like motivated and excited to go for.
There's a lot of agency from founders. Like, everyone's just taking it and running with it, which is cool.
Yeah, and I think with this, there's a lot of big decisions that we need to make. This is true obviously on the capabilities work, but it's also true on the product side. It's true on go-to-market and so on. And so, we have a lot of fun. I mean, it really is a lot of very, very late nights. Folks are pretty regularly in past midnight.
What's an example of a math problem you give the team that was too hard for our listeners?
Okay, so one of the games that we play is there's a game called 24 where you put out 4 cards. If we have a deck of cards, we can play, but it's you put out 4 cards, okay. and let's say it's 8, 7, 4, and 2.
Okay. 8, 7, 4, and 2.
And so now the question is, you have to. I'm gonna make you do this, by the way.
Yeah, let's do it.
Okay, so you have to. You can use any operations: add, subtract, multiply, divide.
Okay.
And you have to use all 4 of the numbers. You can put them in any order. You can use parentheses or whatever, and you have to make that equal 24. You have to do an expression with all 4 of these numbers.
Got it. So you have to use these 4 numbers as fast as possible to get to 20.
Yeah, as fast as possible.
But you can't reuse a number.
You can't reuse a number.
So 7 times 4 minus 8 over 2.
Great. Yeah. So 8 over 2 is 4. 7 times 4 is 28. 28 minus 4 is 24.
There we go.
Very fast. It's good. It's good. Yeah. So at some point that got too easy, and then we did it with 6 cards, and then you were making 163, and then there was like 8 cards and making the current year and stuff. And then this is a game that we used to play all the time when we were growing up and stuff. But it's there's been some fun ones. Yeah. So I'll give a hard one, which is
give us a harder one for our listeners. Yeah.
Yeah. So you have the numbers 3, 4, 5, 8, and 13.
Okay.
And you're trying to make 198.
You're trying to make 198.
Yeah.
All right. And so we're gonna like pause and fast forward this now.
Yeah.
And then 1 second later, Joe comes out with, okay,
Yeah.
no, pause. Okay. Okay. But you can't just combine them. You have to do operations, basically. That's kind of cool. So it's like, what is like 4 to the power of... Yeah, this is a lot harder than the other one.
This is harder,
I can probably get it, actually. Just give me a second for fun.
It's tough. Yeah. I think it would take a while. Yeah.
Got it. Okay. Well, we're yeah. No. Hey, turn it off. Turn it off.
I can just tell you that. I'll just tell you.
Okay, tell us. Okay.
So you do 13 divided by 4.
13
the
divided by
really
4.
sick thing. Yeah,
That's actually crazy. See,
and
I
then
would
you-
not have intuitively got
Yeah,
that
and then
one.
you add 5.
3.25, so 8.25.
Yeah. 8.25, and
Yeah.
then that times 8 is 66, and that times 3 is 188.
Wow.
Which
So it's
is
8.25
really,
times 8 times 3. Yep.
yeah.
That's
So
slightly harder.
there's no way to do it without doing fractions. It was, there are a lot of fun ones like this that
There must be
people
some
ask
other
about.
way
So,
where
yeah.
it's like 3 to the power of 5 and then do something else. You just can't do it. How you tried a bunch.
It's yeah. So there's none. Yeah. Usually it's you're not allowed to use exponents. If you were, you could do a 3 to the 5 minus
that's what I was
4
thinking.
times 8 minus 13.
That's,
which
how,
would
that's,
work.
that's what I was working towards.
But without exponents, I think the only way you can do it is with these fractions.
Fractions.
Yeah. So the
That's
fun
cool.
ones I think are the ones where it's not just integers, that you're working with.
Amazing. Okay, let's do an even harder math problem. First person to solve it in the comments, we're going to send you some swag. Scott, what's a harder one?
All right, let's do it. So I'll give another one of these making a number. So if you have 4, 5, 6, 10, 10, and 10, so 3 10s and then a 4, 5, and a 6, can you make 163? And again, you can only use add, subtract, multiply, divide. You have to use all the numbers once each. You can put them in any order, but your equation has to have exactly 3 10s, for example. You can't have more or less.
All right, audience, go to it. All right. Well, thank you for showing us that. When you're not doing math problems together, which I think is really cool. I remember last time I was Brad, you guys were talking about the future and debating.
Yeah.
And you say you're an optimist because a lot of people in my world, there's like this messianic branch where it's like we're creating this God and everything's gonna be totally different in 10 years. And then like other people are like, oh yeah, it's really negative. It's gonna like be centralized power and control and destroy everything. Whoever gets in charge of the top AI is gonna be negative. And then there's like also the optimistic points of view. Like what's your optimistic point of view here?
Yeah, absolutely. It's the in one line. This is my co-founder Walden says this all the time, which I love, which is we've been spending our whole lives in Minecraft survival mode, and now we're gonna get to play Minecraft creative mode. And that's like the I think that really is like the really exciting future that we're heading towards. I think the main thing I would just call out is like I think human creativity, human passion, desire to build things of meaning, I don't think that stops because we have some really smart AI or anything like that, right?
Yeah.
And I think if anything, we're going to be able to spend a lot more time doing that. We're going to do really cool things. One of the things that I always think about is like, if you just imagine folks from thousands of years ago, looking at us today, like sitting here talking about this, right? And it's funny to think that in the sense that like, probably most of what, most of these white collar jobs out there, it would be crazy for them to even think about it as work. It's like you sit there, you're talking in the room with other people, maybe you're pushing buttons on this thing or whatever, and you call that work. You're not in the fields, you're not actually like pushing things around, right? And I think that we will go through like another level of that, honestly, with AI, where we will similarly, we might still call it work and think of it work, but it's going to look more and more like really pursuing your own passion and building great things and building really cool things. And I think that and I think that that's gonna it's at the end of the day, I think we've made a ton of progress over the last thousands of years, but there is still like a lot of suffering. There's still like a lot of things that we don't need to have, basically. And I think getting to the point where people can really just do what they want to do and build really exciting things and put things into their life's work that they create is really exciting. I mean, it with Devin especially. I mean, we're all programmers ourselves, obviously, and so we love coding. We love building software, and I think one of the big things that is really really exciting about it is, you don't stop building software just because you can have AI that helps you write code, right? I think I think if anything, we're going to have way, way, way more great products, and we're going to have way more great ideas that we're going to be able to bring to reality because it's so easy. Everyone has so many ideas that they have of what they want to do and what they want to build. And and being able to turn that into reality is just really exciting.
So we're recording this before the Reagan Economic Forum I'm going to this week. So I'm thinking in economic terms
Yeah.
right now. And I love what you said with this like positive, like Minecraft creator mode.
Yeah.
And so in economics terms, that means that like productivity goes way, 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 way up, and it's massively disinflationary, and you just create things cheaply, whether it's farming, whether it's building, whether it's healthcare, whether it's education. How do you think of the timeline? I know it's a kind of an unfair question because you're thinking a very positive vision of
Yeah.
this 10 years out. Like, do we start to see productivity just shoot way up in the next few years? Like, when should we expect this, or how do you think about that?
Yeah, and I think we have honestly we have a special lens into this because I'd say code is honestly the fastest growing use case of AI out there, and I think it's I think it is representative in the sense that look, it's in code it is real. It is very clear, you know, that if you're not using AI, you are just slower. But I don't think that you know, I don't think that leads to kind of a negative for us in the sense, if anything, it means that we all get to build a lot more and we all get to do a lot more, right? And so I think that is kind of the shift that we're going to see in a lot of these fields. I think on a per person basis, each person is just going to have their own team of AI assistants that's going to help them do a lot more.
And it's actually amazing if you think about it. The U.S. economy is, well, it's like a $20 trillion economy, depending on different ways of measuring it. So if you make productivity go up 10%, that's a $2 trillion a year, which equity-wise is a $20 trillion thing in 1 year.
Yeah.
Right? So it's even 5% is in the order of a $10 trillion of equity value. So it's actually fascinating. Like the positive sum nature of this all stuff works, it's worth tens of trillions of dollars. And so, like, how do you think of the possible value and opportunity of something like Devin? Like, I think this actually is a multi-trillion-dollar opportunity because it's fixing such a big space. Is that the right way to think about these things?
Yeah, for sure. I mean, I think for us, it is the central question that always roots us in basically all of our product decisions and all of our strategic direction and so on is just like, what is the future of software engineering? You know, I think it's I think in startups people often get caught up in, you know, kind of figuring out fancy tactics and things like that, but it always starts from what is the future and what is the value that we're going to provide. And a lot of it for us is just the fun thing about this space is that the answer to that question basically changes every couple months. In the sense that, you know, you hit a new tier of capabilities, you build models that can do these crazy new things, and that changes the whole experience of like, what is the right way that humans should be working with AI to write code?
What's a recent tier that you feel like you've hit? Can you give us some insight?
Yeah. One of the big ones that we've just rolled out actually is basically the ability for humans and AI to just you can use AI to interactively plan and scope out the task, and then once that's ready, you can just hand that off and go. The similar thing is just even, you know, getting to the point where every time you file a ticket in Slack or Linear or Jira or whatever service you use, you know, it's you just have your coding agent go and work on that, right? Wow. And I think it's crazy to think about because, you know, a few years ago, for example, like the you know, GitHub Copilot and others were kind of some of the first to really kind of pioneer the AI coding space. And, you know, this single line where it would give you a suggestion, which you could tab complete, like that was all you could do in code, you know, and it was because we had models that were pretty exciting, but obviously they weren't good enough that you would trust them with these bigger things, right? And I think one of the really cool things actually is a crazy stat, which is if you look over the past few years since that kind of tab completion era, you can kind of think of an AI model or an AI system in terms of how much work it can do in between interventions from a human, if that makes sense. And so it's like, you know, can it do 5 minutes of human work straight in between, you know, an intervention? And
because once the errors get to be too much, it just has to stop, basically. But it doesn't always know to stop, right?
Yeah. It's like until like the human has to step in and give more feedback or something like that. And the crazy thing is, over the last like 3-4 years, that number has basically it's doubled approximately every 3 months in code. Which is, you know, 2x every 3 months is 4 doubles every year, which is 16x, right? And it's, I mean, it is kind of, you know, over 3 years, that's about 4,000x, which is correct.
What is it over a decade? 2 to the 40.
Which is a lot. It's about 1 trillion X. And
number.
so we'll see how long that continues. And so far it shows no signs of slowing down. But, you know, it really has over the last few years gone from systems where it can just complete the line for you and just do that 2 seconds of typing for you, versus now we have systems that are going to do hours of work. You know, they're going to go build a feature or solve a bug.
I think it's about a quadrillion, by the way, Scott, not a trillion. It's a quadrillion, right? Or am I wrong?
2 to the 40.
Is it? That's a million square. It's a
it's
million
trillion.
squares a trillion. Damn it!
Yeah.
Can we delete that part? Just kidding. I keep trying to get it and I lose. I'm terrible. Yeah, it's a million squares a trillion. This is really bad. This is like I shouldn't challenge him.
You had me.
I got you scared.
Yeah, I know.
That's funny because that would be a big deal if I just okay.
I was
this is
gonna
good.
ask you to cut that in.
No, yeah, no. Don't worry. You're right, Scott. And what does this mean for large organizations? Because there are a bunch of them
Yeah.
adopting it. They're getting more productive.
Yeah.
Like, are they gonna? There is a question. Like, people have stopped hiring quite as many engineers the last few years. Maybe they overhired in 2021 though. Like what should we think about that?
Yeah, no, I think there are certain economic factors that came into there, but I would say it is very clear if with every engineering team. I've never met an engineering team that's told me, all right, we have this project and then we're going to do that project and then we're done. No more software. That's it, right? I mean, every team has 100 things that they want to build and that they want to ship, but they have to pick 4 of them to do this week because that's all they have bandwidth for, right? And I think that I really do just think that the demand for these things is going to grow. One of the things that I think about all the time is, if you think about the best products in the world out there today, right? And in my mind, that's probably, YouTube, Instagram, TikTok, things like that. And obviously they have tons and tons of hours and tons of usage, but they're about as close to perfect as we get in software today, I'd say, where it's, the algorithm is amazing. It knows every little detail about me. It's streaming a ton of data and it's able to do that super efficiently. It never goes down. The product UX is super, super intuitive. It always, it's really easy to understand how to do what you want to do. And that's kind of the top tier, right? And let's say that's, call it 100 million hours of engineering time that we've put into that, across tens of thousands of engineers or something, right? And so that's kind of the absolute top, right? And every tier, every order of magnitude that you go down, you feel it. There are products out there that have tens of millions of hours, and I'm thinking about a lot of banks and healthcare products and things like that, which I use these all the time as well. And you can feel like the difference of the bugs that you run into or little things that are unintuitive or don't quite work or really should be easier. And then you go to the products that have 1 million hours and then 100,000 hours and so on, right? And eventually you get all the way down to your local like school website or something, which is like
you can't use it.
It's from like 2001 or something, and so it's I guess what I would just say is like there's so much more out there to build, and I think it is very clear that there are a lot of products and a lot of project experiences that could really use like a lot more care and a lot more effort. And if anything, we're only bottlenecked by how much we can build. So
I'm seeing later today my friend who's like using AI to like build roads with like construction machines and stuff and other things. And I feel like, do you think like all these new possibilities are going to be made easier from what you're doing? Like, are we going to be able to all of a sudden train things to do things they couldn't do before?
Yeah. So I think it's we're entirely focused with software engineering, and there's I think a lot of bespoke problems in code, and that's like what we want to spend all of our time on. But yeah, I think it's happening everywhere. And to your point, I think there is kind of this like cross acceleration, right? I mean, there are a lot of companies that hire software engineers, not just software companies, right? And I think in general, there's a lot of things that we can just continue to make more and more, to just keep accelerating.
Software engineering does seem to be like the highest level of abstraction for doing things in the world, I guess, is like the leverage point for everything else. Like, so, what are you most inspired by in terms of like recent breakthroughs otherwise? Like what else is most exciting to you? Yeah.
I mean, it's honestly, it was a pretty exciting moment for me to get to see. There's been a few things that came out over the last year. Google had a really amazing result where they got a silver medal at the International Math Olympiad. And then OpenAI had a really great result where they got to approximately the top 100 competitors in the world in competitive programming Olympiads. And it is crazy. Yeah. I feel like I've had my AlphaGo moment, over the last year to kind of seeing that. And it is really, really cool, and I think what it kind of shows, I would say, is actually, I think we're at a point now where intelligence actually isn't the bottleneck, if that makes sense. I think these models are capable of solving some really, really hard problems. And a lot of the work that's being done right now is just figuring out how to make the models really good at your hard problems, and there's obviously a lot of specificity, this is true in software engineering. There's things that you spend years and years on learning all the details of how does this thing work? How do you use this library? What does this mean? How do I debug this error or whatever, right? And that's a lot of the kind of more practical work I think that's happening everywhere in AI right now, where it's yeah, we've shown that the models are capable of doing some really, really hard stuff. So.
And so, Scott, to end this here, I love that you're building probably one of the most advanced companies in the world in this space, creating the future. You're doing it in America. You said you're an optimist. You're an American. Why is America the right place for this? Like, are you proud to be an American? Like, what's it have to do with what you're doing?
Yeah, well, I'm very proud to be an American, I'd say, and I mean, I think a lot of it is just, is believing in merit, I would say, in one line. I mean, I think that I think innovation is incredibly important, and I think that it's, if anything, over the next few years is only going to become more important. And I think making sure we have the right culture and the right circumstances and everything that allow folks to just build new things and come up with new ideas and iterate and try things. And many of those will not work, but some of those will. And I think that's a lot of what's really beautiful, I'd say, about the American spirit.
I love it. I mean, if it does work, it looks like it's going to create a really bright future where we go into. You said, would you say it was Minecraft? What?
Minecraft creative mode. Yeah.
I love it. I love it. It's a very positive vision to end on. Scott, thanks for joining us.
Yeah, thank you so much for having me.